This is an answer key for the 7th grade practice test. So we've been working on chapter 2. We've been including integer rules with decimals, fractions, also whole numbers. And we want to show kind of our knowledge of that in our practice test to be ready for the real thing next week. So this would actually be due Wednesday, the day of your test. And that's the Wednesday after break. This is a chance for you to go through and make sure that things are going well for you and that you're feeling prepared. I don't know if I can get this exposure a little bit better so that we can see things or not. If you take a look, the first section says we want to evaluate each expression. Now be careful. I do have a combination of operations I see happening here. I have some integers. I have over here some fractions. So a lot of rules to keep in mind, even some decimals down below. So let's take this first one. Negative 16 plus a negative 13. Well, hopefully you remember that when I'm talking about addition, I can use same signs, add and keep if I have negatives plus more negatives. And 16 plus 13 is actually 29. But remember we said and keep. We're going to keep it negative. Negatives plus more negatives make several negatives. Number 2, these are again positive and a negative integer. There's some subtraction happening here. So what we've learned to do is add the opposite. Or maybe from the song, change a minus to a plus, change the sign of next. Now if you notice I have positives plus more positives once I make that step. So this is another example of same signs, add and keep. So 300 plus 100 is 400, and 29 plus 4 is 33. So it looks like I'm going to get 433. Now would this one be positive or negative? Hopefully you would say to yourself, positive, because I had positives and more positives. I'm going to get a lot of positives. I'm keeping the sign. Let's take a look at number 3. This one's interesting because it involves fractions. And remember that this dot is telling us we're going to use multiplication. Well, to start with, I noticed that I could maybe consider some cross-simplifying here. I noticed something that both 27 and a negative 9 share. And again, I might move this negative into my numerator. We kind of model that in the classroom quite a bit. So they both share a common factor of 9. I could divide them both by 9. To do that, 9 goes into 27 3 times, and 9 goes into 9 once. But this was a negative 9 divided by 9, so that will get me a negative 1 instead. Notice if I look at this 5 and this 15 across from each other, there's more cross simplification that I can use. Well, 5 and 15 both divide by 5. 5 goes into 5 one time, and 5 goes into 15 3 times. I could do a rewrite step here. I have 1/3 times a negative 1/3. And a positive times a negative will get me a negative answer. 1 times a negative 1 is a negative 1. And 3 times 3 is 9. Looks like I'll get a negative 1/9. Remember, you could write this as 1/9 with the 9 looking negative, or you could write it as a negative quantity. These are all true answers. Let's take a look at this number 4 with some integers, and I notice that this is division. So a negative divided by a negative, I know I'm going to get a positive answer. We just want to figure out what that's going to look like. So maybe I set up a long division for myself and say how many times does 4 go into 6? Well, it definitely goes in there once, and 1 times 4 is 4. When I subtract, I'm left with 2, and I'll bring down the next digit to give myself 28 divided by 4 is 7. 7 times 4 is indeed 28, and it looks like I get an answer of 17. Remember, there's agreement here, so we could write an A or we could show a smiley face. Agreement gets me a positive result. Negatives divided by negatives, well, they both hate Brussels sprouts. Well, they get a positive answer. I personally like Brussels sprouts. We're ready for some more challenging problems, and this is really what we've been building up to in our unit. So this is probably as difficult as it could get because I notice we have decimals, we have some fractions, and some more decimals, and a lot of different operations happening here. There's an addition, a subtraction, another multiplication, and a subtraction happening back here. So we have to think in order of PEMDAS or GEMDAS. What would you do first? Well, if there were parentheses, I'd consider it, but there aren't any. If there were exponents, I'd take care of that next, but I don't see any. And I guess I should maybe backtrack and say there are no parentheses except for here. This parenthesis set is really housing the negative 6.5 or negative 6 5/10. I guess another thought there that I didn't show you, we could also distribute this negative to it, but I won't do that today because I think that's kind of a new strategy that we'll see in the next unit. So next I can look for multiplication or division in order from left to right. I do have some of that happening right here. I have this 3 2/5 times 4/10. Well, one of these is a fraction, the other one seems to be a decimal, and I really would like these all in the same format. It just might be easier to work with. So off to the side here, I might tell you that I know 3 2/5 is really the same as 3 4/10. Notice I changed my denominator to tenths because I wanted to make a friendly denominator for decimals. So I know 5 times 2 gets me 10, so on the top 2 times 2 got me that 4. Could we rewrite this now in a decimal form? Sure, it'd be 3 4/10, with that 4 being in the tenths place. So if I were to do a rewrite step here, I could really replace this mixed number with 3 4/10. And next I'd need to multiply it times 0 4/10. So off to the side so I don't ruin my pizza, I'm going to take 3 4/10 times 0 4/10. 4 times 4 is 16, regroup the 1, 4 times 3 is 12, plus 1 more makes 13. Now be careful, a lot of students are unsure about what to do with this decimal, especially because accidentally this one seems to be aligned, but this is multiplication, isn't it? So this is where we talk about a decimal bank. We talk about how many places I need to save in the decimal. Well, there's one decimal place behind this first digit, or the first number here, and there's one decimal place behind the second number here. So I would say there's a total of 2 decimal jumps that happened in the original problem. Another way of saying that is the first number is divided by 10 one time, and the next number was divided by 10 one time. Well, I really want to divide by 10 twice. So here we'd start at the back of the number, and dividing by 10 once, twice will move my decimal 2 places. It's the same as dividing by, say, 100. After I divide by 10, divide by 10 again. The same thing could be accomplished by dividing by 100. Let's take this piece and go ahead and plug it in here. So we'll come back to our original problem and we'll transfer that 1 3600ths, and I'll bring everything else down that we haven't dealt with yet. Oops, that's an addition. Be careful. Now if you look, the only thing I have left here, there's no more multiplication or division to deal with, so those are done, but there is addition or subtraction in order from left to right. So I really want to handle that next. Well, if you remember, in our subtractions, we oftentimes will change them to make them more of our addition rules. We will change them to add the opposite, or change a minus to a plus, change the sign of next. I see another subtraction coming, so I would change the minus to a plus, change the sign of next, or add the opposite. Well, the opposite of a negative 6 5/10 is a positive 6 5/10. Now really I have my addition rules and I can use them all the way through from left to right. So let's think. I have 18 2/10 plus 7 3/10. If you need to off to the side, you could stack these up. And remember, in decimal addition, it is critical that we line up our decimal and our place value so that we have the same size parts being added together. 2/10 and 3/10 gets me 5/10. 8 ones plus 7 ones gets me 15 ones, and I'll regroup. Now I have 110 plus 110 gets me 2 10s. And remember, in this situation, the decimal comes straight down. When we're adding or subtracting, decimals are aligned and the decimal drops into our answer. So I'm going to copy this over here. I have 25 and 5/10. But don't forget, there's a lot happening back here, so we'll transfer everything down, watching out for our positives and our negatives the best we can. And I think we're ready for the next step. Well, moving next in order from left to right, I have a positive plus a negative. I'm going to have to use a different skill here. This is actually different signs, so I'm going to have to use different signs subtract. Whatever 25 and 5/10 is, take away 1 3600ths. So off to the side here, kind of running out of space, but I'll move this way. I'm going to show you 25 and 5/10, and I'm going to line up my decimals. If you remember, I'm taking away 1 3600ths. I might need a placeholder back here just to be able to show that there's something sitting in the hundreds place. 0 take away 6, not too easy to do, so we'll do a regroup. We'll turn it into 10. 10 take away 6 is 4. 4 take away 3 is 1. This decimal is again in a subtraction problem, so it gets to come straight down into my answer, or my difference. 5 take away 1 is 4, and 2 take away nothing, if you want a placeholder there, would still be 2. Looks like I'm going to get 24 and 1400ths from this. 24 and 1400ths. Now I must say, be careful. Would this be positive or negative? Well, after we do difference sign subtract, we keep the sign of the farther number. Which number is farther? Is a positive 25 farther than a negative 1? The answer is yes, so I'm going to get a positive result. The last step I would bring down is to add the 6 and 5/10. Remember, this is decimal addition. We want to make sure that we're lining up our decimals. So somewhere off to the side here, I need to show some more work. I will do a rewrite step. I have 24 and 1400ths, and I am adding 6 and 5/10. Notice my decimal has to be aligned, so I might need to put a placeholder at the back. What's 4 and 0? 4 and 5 and 1, 6. We'll bring our decimal down into our sum. This is an addition problem, so this is a sum. 6 and 4 is 10, and we'll regroup that 1, and 1 and 2 more makes 3. Looks like I'm going to get 30 and 6400ths. Let's come back to our pizza that's happening here, and if I could fit my pepperoni in here, I definitely would. Unfortunately, I've kind of run out of space, so I think this would be a better problem for some line paper. 30 and 6400ths. Should this be positive or negative? Well, if you go back, the last step showed me positives plus more positives. I should get the same result, same sign, add and keep. That was this last line of work. Notice that this is an okay answer. It's possible that if you took the time to change all of these other numbers into a fraction form, your answer might look a little bit different. So how might it look? Well, 30 and 6400ths would mean exactly the same thing. But that wouldn't be in simplest form, would it? I can divide both 64 and 100 by 4. So I think I would get 30 and 16 25ths. Yep, 30 and 16 25ths is another good answer. So these are really equivalent. And again, I don't really like this idea of Dr. Seuss. I should have planned better with some more paper in front of us today. But either decimal or fraction form would be appropriate because I had either to choose from in the original problem. The next one we're going to take a look at is number 6. And I think I'm getting wise here. I'm going to grab some separate paper that I have this way, and we're going to copy it down. So number 6. Notice again we have a combination of decimals and a fraction mixed in there. So they're really challenging me to include all kinds of skills that I've learned. My integer skills, my decimal skills, my fraction skills combined. Negative 39 and 8500ths plus 41 and 7600ths. That's a division sign there. This is being divided by 1 and 2/10. And then I'm adding 5/8 times the quantity of negative 0 and 6/10. Oops, kind of went off the charts here. I think I have it copied well. Double check. I have 1, 2 negatives, 1, 2 negatives, 1, 2, 3 positives, 1, 2, 3 positives. Looks okay. I think we're ready to give this a try. So again, I'm thinking of PEMDAS or GEMDAS. Potato, potato. You can choose either way to think of this problem. Are there parentheses? And while the answer might be yes, notice that they're just housing a negative, so not much I can do here. Are there exponents? Not in this problem. Is there multiplication or division in order from left to right? Sure is. So let's take a look. Where's that multiplication? Oh, here's a multiplication, but notice there was a division before it. And division and multiplication are buddies. They happen on the same level of order of operations, so we're really going to take this division first. So I need to think of 41 and 7600ths divided by 1 and 2/10. Off to the side, because you don't want to ruin your pizza here, your nice organization of line by line work, I'm going to take 41 and 7600ths and divide by 1 and 2/10. Well, remember that I like to divide when my divisor is a whole number. So to get that, I would really move the decimal back one place. Why did that work? Because secretly you multiplied by a magical number, 10. If you do that to the outside, or in this case, if you do that to the denominator, you also have to do that to the numerator, or in this case, the dividend. So 41 and 7600ths will become 417 and 6/10. We're showing that we could multiply both numbers by 10 to keep their balance. Well, remember, this new decimal gets to move into my quotient, and I'm really ready to divide. I say, does 12 go into 4? And the answer would be no. I'd appreciate a placeholder here so that your alignment stays strong. Does 12 go into 41? The answer is yes, 3 times, because 3 times 12 is 36. When you subtract, you're going to be left with 5. You might do a little regroup there to see it. And double check, is 5 smaller than 12? The answer is yes. So we're going to bring down the next digit and know that things are going well. I can treat this as 57 divided by 12. Well, I know 12 times 4 gets me pretty close. 4 times 12 is actually 48. We'll do a little regroup or subtraction or counting on or counting down, and you'll get 9 left. Is 9 smaller than your divisor? Yes, things are going well. Bring down the next digit. And does 12 go into 96? The answer is actually yes. It goes in there 8 times. Notice this 8 landed behind my decimal. That's because the 6 was behind my decimal. So everything should be aligned in this nice orderly column. And 8 times 12 is actually 96. Good, we found a terminating decimal. That's what we would hope would happen in this situation. So I'm going to go ahead and transfer this over here to the original problem. 34 and 8/10. Let's keep in mind integers have happened a lot in this worksheet so far, or in this practice test. So a positive divided by a positive is still a positive. This looks good so far. We'll bring everything else down. The pieces that we haven't used, the terms that we still need to simplify, still need to show up in this line of work. That should be a negative 0 and 6/10. All right, good. We took care of multiplication and division. We're moving from left to right, but is there more to be done? The answer is yes. There's still a multiplication back here, isn't there? I don't know about you, but this 5/8 times a negative 6/10 might be a little bit hard to see. We could turn 5/8 maybe into a decimal. That would be a possibility. Or I could even think of this 6/10 as maybe a fraction. I think because everything else is decimals, I might try to turn this into one now. So this is the same as the idea of m over n. It's where we take our numerator and divide by our denominator. And you're also allowed to use a calculator on this test as long as you show your work. So I'm just going to take 5 divided by 8 and see what I get. 8 does not go into 5, so I'll put a 0 here. And I want to remember to bring my decimal into my quotient. 8 does go into 50, so if I take one more digit here, it would go in there 6 times, because 6 times 8 is 48. Subtracting, you'll get 2, and it is smaller than your divisor, so things are going well. We'll bring down a 0. 8 goes into 20, twice I should say, because 2 times 8 is 16. And when you subtract, with a little regroup or counting up or down, you can get a 4 here. And 4 is smaller than your divisor, so we'll bring down the next digit. 8 does go into 40. It goes in there 5 times. We'll put a 5 in our quotient, and 5 times 8 is in fact 40. Looks like this is another terminator. This is a terminating decimal. Let's go ahead and plug this piece back into our problem. It looks like I get 0 and 625 thousandths times a negative 0 and 6/10. And notice those parentheses are really just housing that negative next to him. I'll bring everything else down that we haven't dealt with yet. And decide what to do next here. Well, really, the only thing I accomplished in this line of work was turning one of these fractional pieces into a decimal. I still have some multiplication to show, so somewhere off to the side, so that we don't ruin our organization, our line-by-line work, I'm going to show you 0 and 625 thousandths times 0 and 6/10. Notice I took the negative off of this because in a minute I don't want to be confused and think that this is a subtraction. I could already tell myself, hey, these signs don't get along, there's disagreement here. I'm going to get a negative result. Maybe a good idea to show that. 6 times 5 is 30, we'll keep the 0, regroup the 3. 6 times 2 is 12, plus 3 more is 15. We'll keep the 5, regroup the 1. 6 times 6 is 36, plus 1 more makes 37. And now we have to take a look at these decimals. All decimals or all numbers get 1 decimal. So this won't work very well. If I decide to bring these down, I'd have a real problem on my hands. This must be a different rule, and we call this the decimal bank. Again, we're trying to figure out what did they divide this number by. Well, they divided by 10 once, twice, 3 times. They really divided by 1,000, or 10 by 3 times. They really divided by 10 3 times, is what I meant to say there. If you take a look at this next one, the decimal's over 1 place, so I'll save 1 place in the bank. Or it's the same as dividing by 10 once. Only 1 time divided by 10 would move a decimal to the left 1 spot. Well, 3 plus 1 makes 4. I want to divide the final answer 4 times, meaning I want to move my decimal 4 times into my final product. So I count my jumps, 1, 2, 3, 4. If you want to show an arrow, we're heading this way. because in division, dividing by 10, we make numbers look smaller, don't we? Looks like I'm going to get a negative 375 thousandths. Hi, Marquita.
Hi.
We'll bring everything else down that we haven't dealt with yet and see if we can simplify this last step or two. So notice we've taken care of the parentheses. There's no more multiplication or division, but there is addition and subtraction to deal with from left to right. So that's the next thing we want to tune into. Well, notice I only have additions, so I really can go in order here from left to right. I can take a negative plus a positive, and I know that means I'm going to have to use different sign subtract. Well, off to the side here, I might show my work with my decimal alignment. I might need to put a placeholder on the back of this, 34 8/10 to make it look like 34 80/100. And again, this is a subtraction, so 5 take away 0 is 5, 8 take away 8 is 0. My decimal can move down. 9 take away 4 is 5, and 3 take away 3 is 0. It looks to me like I'm going to get 5 5/100. So let's write that down here, 5 5/100. Would this be a positive or a negative? Keep the sign of the farther number. Well, a negative 39 is more negative than a positive 34 is positive. There were more negatives. It's a negative result. Bring down the last term. Take away 0 and 375 thousandths. Oh, if you notice, I have negatives plus negatives. This is a same sign add and keep situation. So those rules that we learned early in the unit really help me now. And I also have to remember we're working with decimals, so to add them up, I'm going to have to line them up. Off to the side, let's give that a try. I have 5 5/100 plus 0 and 375 thousandths. If you notice, it kind of looks like I'm missing something here. You might want to put in a placeholder in that thousandths place. Well, what's 0 plus 5? You'd say 5, and 5 and 7 is 12. We'll regroup the 1. 1 and 3 is 4. We'll bring down our decimal, and 5 plus nothing, well, still 5. Looks like I'm close to a final answer. Let's go ahead and show that over here in my pizza, or in my organized line-by-line work. 5 425 thousandths. But what's wrong here? Did you catch something? Something a little bit dangerous along the way? It says same sign, add and keep. I had negatives plus more negatives. What should my answer get? A negative. This is a final answer. But keep in mind, if you go back to the original problem, there's something else that you could have chosen to do. Perhaps you changed all of these into fraction form. Personally, I probably wouldn't, because I noticed that my decimals outweigh or outnumber my fraction. But if you had done that, there might be another good answer that you would see on your paper right now. Well, I could start with this as a mixed number. A negative 5 425 thousandths would look like this. But I would want to simplify that, keep it in simplest form. So I'm trying to think of a number that divides nicely into 425 and 1000. I know 25 will. Divide the top and the bottom by 25, see what we get. Well, if I think quarters, it would take, let's see here, 4 quarters to make $1, and I want $4. So 4 times 4 is 16. 16 quarters would get me $4, and I need one more to get that 25 cents. Looks like I'll get 17 here. 25 times 17 should get me 425. And how about how many quarters go into, say, 100? You'd say 4, but you want a 0 back there, right? So we'd say this is 17/40ths. Negative 5 17/40ths is also a good answer. Now, it's not always okay to give a fraction or a decimal. It is today because these problems started with a combination of decimals and fractions. So whatever they give me, I can give them back. The last one we're going to look at here is number 7 on the front page. This will end our part 1 video, at least page 1 of our practice test. Notice I have 1 4/7, and it's written over top of a negative 15/21 in the denominator. What does that mean I should do? Doesn't this secretly mean division? Oh yeah, numerator divided by denominator, kind of like m divided by n, but this is considered a complex fraction with that mixed number sitting there. We'll just do a rewrite step. Why don't we look at this horizontally instead? It's kind of strange to see that negative on the outside of this fraction also. I don't see that a whole lot. Well, if this really is fraction division, I notice that I've got a mixed number here, and I might have to turn that into something that looks more like m over n, or an improper fraction. So what is 7 times 1? 7 plus 1 more, 4. Oops, I think I said that wrong. 7 times 1 is 7, plus 4 more would make 11. and we keep our denominator the same. Sometimes we call this MAC, multiply, add, and keep that denominator. I have 11/7, and I'm going to divide by this negative 15 over 21. Okay. So I've turned this from a mixed number into an improper fraction, and I'm really ready to follow my fraction rules, which would say, if you look in your notes by the way, to use reciprocal multiplication, or multiply by the reciprocal, or sometimes we write freeze, change, flip. So which one gets frozen? Which one gets flipped? Freeze the first fraction. Let's rewrite it. This is 11/7. We change to multiplication, and we want to show the reciprocal of this number. So if I were to show a reciprocal, the numerator and the denominator switch positions. I'll get 21/15. What about this negative on the outside? Isn't this really saying that it's a negative times this, or -1 times this quantity? Won't that make this quantity negative? The answer is yes. So I usually show my negatives in the numerator. I'll do that at this point. Ooh, we have multiplication. Time for some cross simplifying if we can. And I notice 7 and 21 both share a factor of 7. 7 divided by 7 is 1. And negative 21 divided by 7 is a -3. We could do a rewrite step here if you want, or you could carefully probably multiply across. So let's see here. What's 11 times a -3? Hopefully you'd say -33. And what's 1 times a +15? Hopefully you'd say 15. This looks like a possible answer, and we did start with fractions, so it's good to give them fractions back, but this isn't done yet. Notice I have an improper fraction here, and because I started with mixed numbers, it might be appropriate to take it back to mixed number form. I also noticed something else. These both would simplify. They both would divide by a common factor. So let's look at that. 15 would go into 33 how many times? Well, twice, because 2 times 15 is 30. If we use up 30 little pieces, how many would be left? 3 of those 15. Notice this was a negative quantity, so I get a negative result. We are almost there. This is not a final answer, because if I look at the fraction now, I can see that simplification that could happen. I know I can divide the top and the bottom, the numerator and denominator, by the same common factor. They both divide by 3. Looks like I'm going to get a result of -2 and 1/5. That's a final answer. Should I get a decimal in this problem? Should I see a decimal as a result or a solution? The answer is no. Why? Because I started with only fractions and mixed numbers. I need to get only a fraction or mixed number back. This ends part 1, or page 1 of your practice test for 7th grade, chapter 2. So working with those rational number skills, this is a chance for you to make some corrections if you need to, and rehearse the pieces that are kind of getting in the way for you, something that you might see on the test soon.